So far what we have seen is the decisions involved in an inventory planning problem and the costs associated with the decision making. Now let us explore some models for addressing the inventory planning problems. For the moment, we shall keep aside the issue of uncertainty in demand and look at a situation of known demand. Of course, uncertainty is characteristic of real life situations and is indeed very important. However, we shall introduce this aspect of uncertainty after we develop some basic insights with the simplistic model where demand uncertainty is not included. Remember, we need to answer the how much and the when questions in any inventory planning problem. Let us say we are planning for an annual demand of about 10,000. Let me call it as D equal to 10,000. D means demand, let us say. Let's find out what happens when we try alternative quantities of order. So let's denote this order quantity as Q. So for a given demand D, I can keep changing Q, the order quantity, and find out what will really happen. So here is a table in which we have set it up. The demand is 10,000 as we talked about. Let us say we ordered 5,000. That is our order quantity. That means we would have placed 2 orders, and by the time the order arrived, the maximum inventory would have been 5,000. We would have used it and reached a minimum of 0, in which case we would have actually ordered one more. Again 5,000 would come. So this will go on like that. Remember, we call this a cyclic inventory. So average inventory is maximum plus minimum by 2, which happens to be 2,500. Assuming we ordered 1,000, in which case we would have placed 10 orders because we need 10,000 in all. The maximum inventory is 1,000, the minimum is 0, therefore the average is 500. And if you had placed an order of 10 every time, we would have ended up placing 1,000 orders, 10, 0 and 5. So you see something interesting here. What you find is as the order quantity comes down from 5,000, when you come down to as low as 10, what you find is the number of orders is dramatically increasing, correct? When the order is 5,000, you have only 2 orders. When the order is 10, on the other hand, the number of orders is... So when this goes down, this goes up, vice versa. When this goes up, this comes down. This is a very fundamental structure that we need to understand. And anyway, average inventory and order quantity are very much related. Therefore, if this comes down, this will also comes down, and so on. As we know, there is a certain cost of ordering and a certain cost of carrying inventory. We already saw it in the previous video. Therefore, if we multiply the number of order with the cost of ordering and the average inventory with the cost of carrying inventory, then we will get the total cost of the plan. So with the earlier table, we should be able to do this. We shall take this, the x-axis is the level of inventory and the y-axis is the cost of inventory. So the first thing that we know is carrying cost is a function of the average inventory, and if you look at the earlier table, what we find is it keeps growing in a particular direction. As the order quantity increases, we notice that the average inventory also increases. Therefore, this will be the total cost of carrying inventory for a certain decision. Now, if you look at the order, when the level of inventory was very low, the number of orders are very high. Therefore, the ordering cost will be something like this, right? If you order the entire material in one lot, you will incur very little ordering cost. That is what is indicated here. So this cost is going to be the total cost of ordering the inventory. And one can add up these two, which will be the total cost of the plan itself. So what might happen is it will be something like this. and so this would be the total cost of the plan. What does that mean? That means, suppose if this is the order quantity, suppose we want this to be the order quantity, so this is going to be the cost of ordering, this is going to be the cost of carrying, therefore this is going to be the total cost. On the other hand, if this is the decision that we want to do, this is the cost of carrying, this is the cost of ordering, therefore this is the total cost of the plan. So if you look at it in this fashion, there will be a minimum total cost and there is a corresponding quantity which you may call it as economic order quantity, because it's most economical to order this much quantity because both the costs are here, and therefore this is the total cost which is the minimum cost. It cannot be anything lower than this. We notice that the total cost curve has a sort of a boat shape with a flat bottom. Now this flat bottom is a good news. The module is very robust, the model is very robust to the parameters. That's what it actually suggests. So what it really means is that even if we wrongly estimate some of the parameters, the total cost, it doesn't change much, and this quantity that results in the least cost is the economic order quantity.